Right, all right, so now this one I know some people are like, yes, great, we've practiced this, but some little mistakes were being made still here. So expanding this, okay, so it was 2 marks, so it wasn't loads of marks. So you could have, if you'd forgotten what was going on, you could have just literally done the whole x plus h, x plus h, x plus h, and expanded it like that, 2 of the brackets and then the third one. Okay, ideally you would have tried to use the binomial expansion. So remember, the first term starts at the power, and then what happens?
Then it's 3, and then the x goes up 1 and the h goes up.
Good, so the x, I'm going to leave a gap on purpose. So the x squared, x's go down 1, and then the h's come into play, yes?
Yeah.
And then so that becomes x, h, and then plus h cubed. Yes, so that's okay. But what has to go in the middle here?
The number
The binomial, the Pascal's triangles, yes? So that was 1, 1, 1, 1, 2, 1. We want the third row, so it would be 1, 3, 3, 1. So the 1's already there, 3, 3. Oh, I missed a square there. Okay? So that should have been a good 2 marks, yes? I think lots of people did do that. Now this, remember, so now you're substituting. This means that you're, instead of writing x, anywhere you see x in your expression, you're going to write x plus h.
Right.
Okay? So you write x plus h cubed here, minus 4 lots of x plus 1. Now, a few of you forgot the plus 1. Unfortunately, that made everything else go a bit pear-shaped. Okay, so that's that. And then we are taking away. Now, what did I say was super important when we do here? Brackets. And some people ignored Miss Harrison when I said.
I didn't ignore you, Miss Harrison.
Good girl, darling. Over h. Okay, so that's literally just using this formula here, sticking those things in. Yeah? Tell me if I'm going too fast. Right, so now we actually have to do these things. Well, they asked us to do this in part A. There was a reason for that, so you can go straight into it here. So we've got x cubed plus, oh my god, yes, plus 3x squared h plus 3x h squared plus h cubed. So that's that. Minus 4x, I'm going to expand it, minus 4h. You all happy with that?
Mm-hmm.
And then this plus 1 is still there. And then the reason that the brackets was important is because we're taking away all of these 3. So that would be minus x cubed plus 4x minus 1 over h. Okay, so mathematically that shouldn't be a challenge. We should be feeling good about ourselves here. And then remember, there should be lots of crossing out going on. Now, I think some people remembered that lots of crossing out went on, and so they just merrily did some crossing out, even though they perhaps shouldn't have done, or was like, she may not notice, let's just go with it. So this goes with this, this goes with this, and this goes with this. And what else do I do now? Do you remember? Factorize. So we're bringing h to the front. So this, I'm left with 3x squared plus 3xh plus h squared minus 4, and that's it.
Minus 4 and plus 4.
That was to see if you were paying attention.
Well done, Lizzie.
If merits were available to IB students, you would have got yourself a little merit just then.
You still have it.
Yeah. Then, obviously, that goes. And the last bit, what do we do?
Substitute.
0.
Substitute 0 in place of the h. So this is going to be 3x squared plus 3x 0 plus 0 squared minus 4. And then obviously these two things are just nothing, so that's 3x squared minus 4. But we knew that that was going to be the derivative anyway. Yes?
Yeah.
Because the plus 1 is just a constant, and that would have gone. Yeah? Okay? You didn't want to write any of this down? Feel a bit worried, Yeah, I just thought it was a good idea to do it. Okay.
You have the answer sheet?
Yeah. That's fine. Alright, so question 2. Part of the graph is shown below. Now, some of you were whinging and moaning at me earlier. You were saying, it was all graphs, it was all graphs. Well, what's calculus all about?
But we haven't seen questions where we have to use a graph.
You didn't have to use the graph.
It was just there as a worksheet.
It's just there.
I'm confused.
I'm sorry, Angel.
That's why I just white out.
Alright, I think I've just moved it and not helpfully. What's going on?
Oh.
Alright, so part A says find f dash x. Okay, so we're looking at the function. Okay, A, we don't know what A is. Okay, so A is going to be in part of our answer. So how do you differentiate this? Who can tell me?
So, because I got this one right. You have to choose.
I'm writing it up here just because it's easier than keep moving it up and down.
Yeah, that's one. So you have to treat it as if it's like a regular differentiation setup. Right? So once you
Don't do it.
3
Otherwise you're not going to make it to the next birthday.
Oh. 3x squared minus 5x. That's right.
Okay. Pretty straightforward, yes?
Yeah.
Oh my god, what is going on?
I think it needs to be calculated.
Alright, so then says the graph of f even, has a gradient of 3 at the point P. Now, why is it talked about the word gradient? You really genuinely don't know.
Remember the denormals?
Yeah, it's yeah.
The tangent, I figured that out.
Yeah, I got that. I don't really. And then whatever else.
Well, then you also knew it was x was 1, so then you knew you could immediately substitute the x, and then you knew the m was 3. So then you just like, if you knew mx plus c. Okay, sorry. So you're looking at me.
I got that.
No, so totally Natalie. So we know that f dash x represents the gradient.
Yes.
Yes?
Yeah.
Yeah. So we know. Oh, what was it? 3ax squared.
Yeah, minus 12x.
That's right. Thanks. So this represents the gradient. Yes. We know that the gradient is what?
3.
3.
So you said 3. Oh,
Okay, so it equals 3 when
X
is equal to 1.
to find a.
Because that's here, at that point P.
So you just substitute 1 in.
So you're going to put 1 into the x's and rearrange it.
Oh my, wow, I feel good.
This is
But I don't remember you saying that equals the gradient.
That's funny.
Oh, Angel,
I don't remember that.
I don't mean to be harsh, but I think I could find several videos of me talking about
What
calculus
was it? The
and
booklet? Like this booklet?
but that's by first principles. By finding the derivative, but finding the derivative will allow you to calculate the gradient at any given
That doesn't
value.
mean it represents the gradient. That you just used that term before. It needs to be clarified. I'm serious.
It's the look on her face.
here that you are blaming me because you're saying I didn't tell you it was the gradient. I've said it 400 times. Darling, the mere fact that we're going through something and you don't even have a pen in your hand.
That's the answer sheet. Natalie hasn't done anything either.
Natalie has it right, sis.
So what?
But darling, you're saying, is it written down in here? And I said, I've said it. You said, but it's not written. So write it. I can't write everything I say into the sheet. You have to take responsibility for doing some of it
Well, I
yourself. What do you mean you know that now?
Because you just told me. Just now.
Just now. That's the first time I've ever told you.
Maybe, yes.
I'm not having this, Tamia, no. Right, so you're going to substitute the value of 1 into here. So you've got 3a1 squared minus 12 lots of 1 equals 3. Rearrange that. I forget, what's the value of a?
5.
So a works out to be 5. There you go, that's your full marks. Okay? Next question.
I don't even know how to do this thing. This one. No,
Alright, oh, you lot. It's a cube root of x to the power 4.
Roots are in the ground.
So we know roots go to the ground, exactly, and powerful things go on the top. So we cannot differentiate something when it looks like this. You have to rewrite it. So how is that rewritten? I won't ask Tamia because obviously I didn't teach you this.
X says a 4 over 3.
Oh, you skipped right to there?
Okay?
I see.
Roots grow in the ground. The power is on the top. It's more powerful.
And then you put.
Okay? So that's fx. Remember, you don't start writing f dash x until you start differentiating it. Yes?
Yeah.
Can you see, there are a lot of these questions that weren't as a nightmare as was made out. But as I said, I think the whole heads were just going, nah, done, I'm done. And it all went pear-shaped from there.
No, I really tried.
I'm not saying you didn't try, darling. So how do we differentiate this? F dash x, what's the rules for differentiating?
You move the power to the front.
So 4/3 x. And what you have to do with this number here?
Subtract 1.
Subtract 1 whole 1. So you've got 4/3. 1 whole 1 would be 3/3, yes? So what's 4/3 take away 3/3? 1/3. What happens to this minus a half?
It goes away.
Just evaporates because it's got no x attached to it. So that's the derivative.
I wonder how I got shoes.
Okay?
What did you get right?
What do you mean you wonder what you put? You put it. You did chuck it in the bin.
No, I folded it, and I put it in my cup.
You probably got that one right. How would you even know?
Exactly.
All right. Okay. Next question. Was that the only question on that one? All right. Okay.
This one.
So let gx be that. Find the two values of x where the tangent to the graph of g is horizontal. Now, I even wrote this on the board. To say, remember, horizontal lines have a certain gradient. What do horizontal lines have a gradient of 0?
That's why I was stumped. I put 0 and I was like, wait, what?
Okay, so if we know that they have horizontal lines have a gradient of 0,
It means it's a quadratic.
what do we know? What do we have to do? We need to find something to tell us about the gradient. What do we do to find something about the gradient? We differentiate it.
And then equals.
So we find g dash x, and we get what? 3x
squared minus 6x minus
9. Okay? Now, some of you you do need to, because the gradient is 0, some of you then started solving this was equal to 0, but you didn't actually show. So it's really important that you actually then say this. Okay? Maybe make comment that the gradient is 0. I don't know. You don't have to, but let me see a 0 here. Now, this is this kind of question would be highly likely to be on a non-calculator. You had your calculators available, so you could have solved this. I remember someone started using the quadratic formula and then didn't put the numbers in there. I don't know what happened. myself, if I was doing this, I'd see that this was 3, 6, and 9, so I would factorise it. So if I was doing this, I would bring the 3 to the front.
Not today.
Okay, because we know how to solve quadratics. We've been doing that since year 10. So then I would have 2 brackets. X goes in the front. I need to find 2 numbers that multiply to give negative 3 and add to give negative 2. So it's going to be negative 3 and positive 1. Remember, this big 3 has nothing to do with it because it has no effect on it. So the values we're looking for is positive 3 or negative 1. Right, that's how I would have done it because I spotted the 3 and I saw that that was easy to factorise. You could have used the quadratic formula. So the quadratic formula, it is on your formula sheets, I'm sure. So it's minus b. Now, someone even, I think, had a equals b equals and c equals and then put the wrong pig in numbers in. So a in this case is 3, b is negative 6, and c is negative 9. If it's minus b, then it would be 6, because it's the opposite, yeah? Excuse me, plus or minus the square root of negative 6 squared minus, oops, that's not written, minus 4, lots of 3, lots of negative 9, over 2 lots of 3. Okay?
I'm like punching myself in the eye.
So 6 plus or minus the square root of negative 6 squared. Again, if you're using your calculator, you can make a mistake, but you know it's positive, so it's 36. You've got negative 4 times 3, and then minus 12 times negative 9.
Positive 136. Is it 96?
I mean, 12 times 9.
That's not it. 80, 98, 98, 70. What's that? 11. And 9. Okay. 108. Yeah. About 3 mentioned.
Good go. Okay. So you've got 6 plus or minus. What's 36 plus 108? I'll give you a clue.
144.
And what's the square root of 144? 12. So you've got 6 plus 12 over 6, or 6 minus 12 over 6. And 6 plus 12 is 18 over 6 is 3. 6 take away 12 is negative 6 over 6 is negative 1. Okay, so you get the same answers, just took in my mind, a lot longer. Yeah?
I'm saying.
But the option was there. You had, as I say, you had that as your option if you wanted to use that method. Or you could have just put it in the calculator solver. Okay? Moving on.
We don't have to look at it. And it's 4. I put in the wrong number.
No way. Which one did you mix up?
Like, let's look at it.
She almost had it. She had the right spirit.
I think, was it you that identified that you had A, B, and C correct, and then you put the wrong numbers in?
No, because I thought, see what happens when I got too cocky with me. I was like, oh, she tricked me, see? She knows she got me. Yeah. That's pretty
I would never try to trick you.
No, what, see, like, yeah. And I cracked the food, and I got too cocky about it.
All right, okay. So show that f-1 equals 1. Okay, so if we're trying to show the f- of anything, we need to find what f- first is. So f-x would be what?
2x minus 1.
2x minus 1, yeah? Okay. Now, what does the fact that they've got a number in here mean we then do?
Substitute.
Okay, so we say that f-1 is going to be 2 lots of 1, take away 1. Yeah? What's 2 lots of 1? 2. Take away 1. Have we shown that that's equal to 1?
Yes.
Like, that was 3 marks. And this was
Catch, and I got it.
Yeah?
Go.
Now, in my mind, that's very generous. Okay? I'm not sure that the questions in these more recent exams, I think these must have been pretty old ones. I don't think they would have been as generous as that these days. But who knows?
Miss Harrison?
Yeah.
Quick question. Can I text my dad? Because I told him to pick me up at 3:15 thinking I was still at field work.
Oh, yeah. All right. The line L is the normal to the graph of f and p. Okay, so remember the gradient talks about the tangent at p, and the normal, what do we know about those gradients?
Negative reciprocal.
The negative reciprocals, okay?
I broke that down.
So this, okay,
Different
let's establish in our heads what this has told us. This has told us that the derivative of the tangent, the gradient of the tangent, where x is 1, is equal to 1. Yes? So we're all happy that that's what that represents. Yes? So that means that if we want to know the gradient of the normal at this same point, when x is 1, what's it going to be?
Negative.
Negative.
Oh, no, I was right.
Yes? So that means that the gradient of the normal is negative 1. Oh, that really doesn't look like it says it is anymore. Okay? So we need to find the whole equation now. Okay? So we need to keep going. So we know that it's y equals negative x plus b. What else do we need to know?
This is the B value.
The b value. Okay? Well, what about, it's at the coordinate p, so we've got our x and our y values. Yes? So then we stick them in. So what's the value of b?
I say that it is 1.
Yeah? So it's y equals negative x plus 1.
You know, I hate doing this because it makes me feel like such a diplomat.
Okay. I'm not sure that's really what we should be thinking. We're still going. The line intersects the graph at another point. Okay, now, this, I appreciate, not really calculus, but remember how I said how lots of calculus questions bring in so many other aspects, so it was hard for us to give you practice stuff. This is something that you should be confident with at this point. We've just worked out the equation of this, L. Yes? We've worked this out to be y equals negative x plus 1. What was this function here?
Asymptotes?
No, what was the equation of this? X squared minus x? Shh, you listen, yes. So the parabola was x squared minus x. This equation here was negative x plus 1. Now, appreciated, if you didn't get part B, you wouldn't have been able to do part C. Okay? So if you were hung up then this would have been an issue. But if you're trying to find where things intersect, what do you then do? Pardon? You put them equal to each other. Yeah. So you'd say negative x plus 1 is equal to x squared minus x. Yeah? Happy with that? Because we're finding intersecting points.
Tell me why I really just messed up all of that. I did that and then I messed up all the signs.
I don't know. Because to solve this, we need to make sure we're equating it to 0. So what I can see, I've got negative x here and here. That can obviously go. So I know that x squared is equal to 1. So what must x be equal to? The square root of 1, which we know in these days is plus or minus 1. Now, that's where they intersect. How many places do they intersect?
2.
2, yes? Here and here. Now they want to know the x coordinate of q. You cannot leave it like that.
Q has to be negative.
Why?
Because it's on the other side.
Yeah. And we knew that the x coordinate of p was 1.
So
Yes? So the x coordinate of q is 1. Negative 1 squared.
Oh my god, oh god.
Like, at least, I didn't want to make you feel rubbish with going through this, but like, I also wanted to make sure that you understood that there weren't really challenging, there weren't questions in here to really push you. I think there was just
I think we all
I think you got so hung up on, you had
graph.
1700 tests, you saw a graph, you're not used to it. I'm really sorry.
I saw it and I was like, oh, it's hard to track out.
Okay, so here we go, part of the graph is shown in this diagram. Oh, why does it keep doing that? We need to find the coordinates of P. Okay, we know that F crosses the y-axis at the point P. Well, what do we know? What do we know about things when they cross the y-axis?
That's the y, I mean the x is 0.
That the value of x is 0, yes? So things cross the y-axis when x is 0. Okay, so what are we going to do? What are we going to do? Stick 0 in place of the x. Yes?
Lord of mercy. Yeah.
So if you know something crosses the x-axis, sorry, the y-axis when x is 0, to find the coordinates of it, you're going to put 0 in place of here, yes? These terms all are going to disappear. What value are you going to be left with? 6. So the coordinates of P must be the coordinates 0, 6. Now, the diagram actually in this case would have also helped you because they've got the picture P and you can see it's here where x is 0, yes? You can also see it's a positive value, so that also helps to see whether you got it right. Well,
just excited that I got a 0 here.
I didn't even know.
alright, it then says find f dash x. Okay, similar principle. F dash x means we're differentiating it. I've lost it now. Can someone tell me how I don't know what the function is.
Oh, x.
Oh, you can just tell me the derivative.
Oh, 3x squared minus 4x plus a.
Yeah.
Oh, see that A really stomped me, see?
It says in terms of.
Now, part 2 says hence find the equation of L in terms of A. So that would indicate that the A is going to be in there somehow. I know. Sorry. So L is the tangent at P. So we know this is our coordinates. So what do we do now?
Oh, I just find the equation of the tangent. Yeah, so I just didn't make you do regular terms.
So we need to find the gradient first, yeah, because we know it's y equals mx plus c. So we need to find the gradient. How do we do that? Substitute 0 into this derivative, yes? Okay, so because we knew that the point P is 0, 6, so we're sticking 0 into here. So we're finding f dash 0. So that's 3 lots of 0 squared minus 4 lots of 0 plus a. Obviously gives us just a. So we have a gradient of a. So that's y equals ax plus c.
Yeah.
Yeah?
Plus a equals a. I see.
No, I'm saying that whole thing.
So that would find.
Sorry, this whole thing, 0 minus 0 equals a.
The line.
See, that's fine because if I didn't get the 6, I wouldn't have got the other one.
Yeah, exactly.
Yeah? Then we know that the coordinate has the point P has the coordinate 0, 6. So remember that's where we chuck this bad boy in here. Yes? So we say 6 is equal to a lots of 0 plus c.
C equals
So this is at the point 0, 6. So c is 6. And so the equation is y equals ax plus 6.
Well, I put 0, 0. I thought that's why. But if I didn't have the other 0, then I would have got this. Oh, yeah.
Okay? Was that too quick? Were those?
Oh, cis.
Alright, so again,
Substitute.
not again. So this one we can't differentiate as it is, so what do we have to do to it first?
rewrite.
Rewrite it. So what does that look like first when it's rewritten? So fx. Notice I haven't written f dash because I'm not differentiating it yet, I'm just rewriting it.
So basically, yeah, Is it to the power of a half?
Yeah.
Maybe I might know what it is.
Okay, so I've rewritten it. Now this is worth 4 marks. I mean, you got more space to this, didn't you? No, or you just did it all at the bottom?
All the bottom.
Right. So, how do we differentiate this? So, A, f dash x. So, power comes in front. Take 1 whole 1 off the power, so that gives us, is that it?
No. What do times by the derivative of the birth?
Times by the derivative of what's inside here. So we times by 4, yes? Gisella's not
That's
correct.
like chain rule.
Chain rule. Okay, a half times 4 is 2. So I would probably simplify this to say this. Now what they're going to do is ask us to put 1 into there. Well, it's worth 4 marks, so to be fair. But you had your calcs available to you for this one. Okay? But 4 plus 5 is 9.
Yeah.
Okay?
Times 2 is on.
Well, no. You've got to follow bed maths.
So I need to do
So you've got to do it to the power negative a half. So remember, negative a half would be, means it looks like this.
Right.
Yes? I combined the thing.
So it's 2 over 3.
So it's 2 over 3. Okay?
At least you kind of saw where I was getting things hard.
Honestly, on papers, I saw there was lots of good stuff there. It was frustrating for me because I know that you know this stuff. It just went pear-shaped in the test. And I don't know. And I'm only imagining that there's pressure and I don't know. I hate it that when you don't do as well as I would like you to, or you would like to on a test. Right, what's this say? Write down G-1. Okay, so it says consider another function. Let R be a point on the graph of G. The x-coordinate of R is 1. The equation of the tangent to the graph is y equals 3x plus 6. So this is where they've kind of given it to you back with information. They've told you what the equation of the tangent was. What does that information tell us then? What does this 3 tell us? The gradient of that graph, yes?
Yeah.
So what does that tell us about the derivative at that point? Has to equal 3.
Okay.
Yes? You know, remember back in those other ones when we were trying to find the equation of the tangent, we differentiated and then subbed the value in. It's not my question, I don't know why I went to that page. Well, here they've told us the equation. We can see what the gradient is, and we're working our way, well, we're not working our way backwards, we're just identifying that's what it is. So, gradient is 3, so that means that G-1 is 3.
Wait, I don't.
Why?
Maybe I'm not following.
Okay.
Oh, well, anything times
The x-coordinate of, no, literally it's just because the gradient of the equation of the line was 3, it must mean that G-1 is 3.
It shows. It's one of the things you can't really explain what it just means.
Because 1 is where R is.
Right.
Oh.
The x-coordinate of R is 1 so-and-so.
Okay.
Yes?
That makes sense, actually.
Okay, so G-x represents gradient anywhere. At R, x is 1. So therefore G-1 will be gradient of tangent when x is 1. Which happens to be 3. Which they told us, well, that's the thing, they didn't tell us in the question, but we can see it quickly, yeah? There's lots of writing, I shouldn't have written it all in that little space, sorry. Okay, so what are we doing here now? We're finding G1. All right, so the tangent, the equation of the tangent, doesn't matter where our function is. If this is our tangent, equation of our tangent, blah, 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 then to find the y coordinate, you can just stick it into this function as well. That wasn't explained very well at all. G-1 tells us the gradient at the point, but since I know the equation of the tangent, if I were to substitute this value into this equation, that must give me the coordinate that it goes through. No, that's really rubbish.
It's just one of them things you do.
Here's a curve, this is a graph, okay? Here is the equation of the tangent, okay? Okay, down here, this x value, let's say this x value here is 3. To find this point here, I could either stick that number 3 into the original function or the equation of the tangent.
Okay.
It will still give me the same value.
That makes sense.
Does that make sense?
Yes.
Let me draw this.
So whether it's because we have the full equation of the tangent graph, then all we need to do is to stick this value of 1 into that, and that will tell us the value of y of that point. And that gives us 9. And that's it. Okay?